has got the handout, right? See, winds यहाँ से ऊपर से कर लेना, because how the question will be, this is the way the questions will be. I'll discuss this handout, Madden-Julian dry cellular meridional circulation. फिर उसमें से obviously we are going to write one wind in detail, that is equatorial westerlies. बाकी trade winds वो सब मैं समझाऊंगा. You go home, आराम से read this entire part. The past year question has been in the form of, this is from D.S. Lal, fine. So the questions generally will come in this modern views about the surface wind system, winds in the tropical region. ऐसे नहीं आएगा trade winds के बारे में लिखो, winds in the tropical region, winds in the subtropical region to subpolar region, and winds in the polar regions. Subtropical winds and the polar winds. This is how the questions will be. And then tricellular meridional. Baki ka is very for a simple reading. You will see the benefit of this book is बहुत simple language में every concept has been explained. It is not as complicated as the Savindra Singh. So we are doing the factors. One factor we have done is, I guess we have finished all the 4 factors. That is pressure gradient force. I'll quickly revise: direction and velocity. Pressure gradient force is always between high pressure to low pressure. Pressure gradient force is always perpendicular to isobars. Fine. And pressure gradient force will not change the direction with the velocity, etc. It does not change. The second kind of a force is the Coriolis effect or the Coriolis force. The Coriolis force is the force of deflection. How is it the force of deflection? It is the force of deflection in the terms of, your presentation is ready? It is the force of deflection in the terms of any wind in the northern hemisphere will be deflected to the right of its direction. Any wind in the northern hemisphere, rather than coming straight, will get deflected to the right of its direction. दोनों right hand side ही है, right of its direction. And any wind in the southern hemisphere, अगर ऐसे जा रही है तो it will get deflected to the left. अगर ऐसे जा रही है तो it will get deflected to the left. अगर ऐसे जा रही है तो it will get deflected to the left of its direction. This is what is the Coriolis force, and it is perpendicular to pressure gradient force, but changes with velocity of winds, not of earth, right? मतलब अभी obviously it is totally dependent on the earth का rotational speed, changes with the velocity, that is more velocity, more deflection. And Coriolis force is inversely proportional to the rotational speed of earth. Fine. The third kind of a force is the frictional force, which retards or reduces the wind speed and hence affects the Coriolis force. And the fourth is centripetal force. यहाँ पे हम रुक गए थे. Clear? With this we come to the 2 new concepts. One concept is that of the geostrophic winds. Centripetal. Centrifugal. Centripetal is towards the center? Yes, it is centripetal only. क्या क्या? हाँ हाँ. यस. हमेशा जो बनाना केक है इक्वेटर पे इतना काम नहीं करेगी. थाईलैंड इक्वेटर पे कहाँ है? थाईलैंड तो अपने लैटिट्यूड्स पे है. नीचे वाली एक भी कंट्री फुटबॉल नहीं खेलती. इंडोनेशिया खेलती है, बट ऑब्वियसली अभी वो क्योंकि डिफ्लेक्शन जो फुटबॉल का, इट इज नथिंग टू डू विद द विंड. अगर विंड के साथ होता तो मेसी और बेकहम नहीं बनते. विंड और एनी मूविंग ऑब्जेक्ट, फुटबॉल में द डिफ्लेक्शन इज ड्यू टू द स्किल ऑफ अ प्लेयर जो कैसे किक मारेगा. अगर नेचुरली फुटबॉल फेंकोगे तो हाँ, बट वो तो स्किल है प्लेयर का. इसलिए तो बेकहम और मेसी अच्छे प्लेयर्स है और मैं यहाँ पे खेल रहा हूँ, पढ़ा रहा हूँ आपको. अगर डिफ्लेक्शन ही विंड के कारण होता तो मैं भी बनाना किक दे देता. फाइन. सो इट इज नथिंग टू डू विद, इट इज डिपेंड ऑन द स्किल ऑफ अ प्लेयर. अंडरस्टैंडिंग? वो तो स्किल के ऊपर है. अगर ये लॉजिक किया तो इंडिया में बॉल स्विंग नहीं होना चाहिए या सिर्फ राइट डायरेक्शन? नहीं, ऐसा कुछ नहीं. इट इज डिपेंड ऑन द स्किल. वो नेचुरल ना आर्टिफिशियल चीज़ों को अलग अलग ये है. बट नेचुरल क्या है जो क्या डिपेंड नहीं करता स्किल के ऊपर? बेसिन में से पानी कैसे घूम रहा है, साइक्लोन्स कैसे घूम रहा है, उनके ऊपर कोरियोलिस फोर्स एक्ट करेगा. यस, इट इज सेंट्रीपिटल फोर्स. डोंट वरी, चेंज करने की ज़रूरत नहीं है. सेंट्रीफ्यूगल, सेंट्रीपिटल फोर्स, एक फोर्स अवे फ्रॉम द सेंटर, एक फोर्स टुवर्ड्स द सेंटर. यू कैन राइट एनीथिंग इसमें. डोंट वरी अबाउट दैट बिकॉज फिर आवर आंसर विल चेंज अकॉर्डिंगली, नथिंग एल्स. And we will do now the geostrophic and gradient wind. As I've already told you, geostrophic wind is the wind that flows parallel to the isobars. Geostrophic wind is that wind in which the speed of the wind is so high, so there are two forces which are acting. One is the pressure gradient force, which is acting perpendicular to the isobars, and there is a Coriolis force which is acting perpendicular to the pressure gradient force. And therefore we have the speed, the direction of the wind that is somewhere in between. Obviously पीछे frictional force भी है, and therefore this three forces are trying to balance each other. ये frictional force भी है. Now when the frictional force is less, the speed of the wind increases. And जब भी speed of the wind increases, the wind will start getting deflected. ऐसे deflect होगी. As the wind will start getting deflected, Coriolis force will start getting perpendicular, acting perpendicular to this. Actual pressure gradient force is to the north, but the Coriolis force, when it acts to the perpendicular to the pressure gradient force, it is perpendicular to the wind direction. So because the wind is getting deflected, pressure gradient force will now, the Coriolis force in the original position will come here, CF1. Wind ka further deflection increases as it goes into the higher latitudes, or as there is the increase in the speed in the terms of jet streams. Coriolis force starts acting here, CF2. Ultimately, there comes a position when the Coriolis force will be equal and opposite to the pressure gradient force, and as a result of this the wind will now start flowing parallel to the isobar. Such kind of winds are known as geostrophic winds. कुछ concept नहीं है, बहुत आसान है ये. Understood? What are the geostrophic winds? The geostrophic winds are, remember, if this is the earth, a wind that rises from here goes up, and now after going upwards it will start getting deflected to either to the right or to the left in the southern hemisphere and the northern and southern hemisphere respectively. So if there is a wind which is going from this to this direction in the upper atmosphere, frictional force is 0, and in the northern hemisphere the wind will start getting deflected to the right. Ultimately Coriolis force and the pressure gradient force इतना ज़्यादा होगा कि wind will start getting deflected to the extreme right, and therefore we will have a jet stream which will be flowing. आप नाम दे दो इसका polar jet stream, आप नाम दे दो इसका subtropical westerly jet stream. Fine. Secondly, if the wind has started rising from here anywhere and it starts going towards the poles, अब दूसरा क्वेश्चन कि पोल्स की तरफ ही क्यों जाएगी? पोल्स की तरफ ही जाएगी क्योंकि यहाँ पे ITCZ इक्वेटर पे कुछ हवा नहीं हो सकती. It will start going towards the poles and it will get deflected to the extreme left, and as a result of this we will have, understand it, now it is facing in my direction, my left is here, southern hemisphere mein. It was first facing in your direction, your right is here, northern hemisphere mein. It will get deflected to the right, left, and therefore it will result into formation of another jet stream in the southern hemisphere. And therefore whether it is the jet stream of northern hemisphere, whether it is jet stream of southern hemisphere, it will always flow from west to east due to the Coriolis force. Getting it? This jet stream is an example of a geostrophic wind. Then we have one special kind of a jet stream which originates over India, and it flows only in the Asia from east to west. Why is this? Apply the Coriolis force. It rises over this part because of the Tibet. Tibet से हवा ऊपर जाती है. ऊपर जाने के बाद it tries to move towards Siberia and it tries to move towards the equator. Siberia वाली हवा हम study नहीं करते because that air becomes very cold and it descends. It does not travel a longer distance. This air comes down to the south, and when it is going towards the equator, India, northern hemisphere or southern hemisphere? India is northern hemisphere. This by the Coriolis force gets deflected to the right, and when it gets deflected to the right, हम इसको कहते हैं tropical easterly jet or Somali jet, right? Because ये जाके फिर settle होगी और सोमालिया. At least ये नाम सुना है tropical easterly jet stream, fine. So all the jet streams in the world, हमने, I am not teaching you why it originates etc. मैं सिर्फ आपको उसकी direction बता रहा हूँ as in the terms of geostrophic winds. All the oceans in the world, all the jet streams in the world will move from west to east except the tropical easterly jet stream, because this is the only jet stream that originates in the monsoon lands of Asia due to the excessive height of the Himalayas. As the Himalayas become hot and it starts going towards the equator and it gets deflected to the right, वो आती है over India as tropical easterly jet stream. ये 3 point लिखने हैं geostrophic winds में. Last point if you want to write is, in the southern hemisphere the westerlies move with such a high speed because of the lack of the land mass कि they are known by roaring 40s, furious 50s and shrieking 60s. Shrieking 60s में the speed is so high, therefore the deflection is high, and they start, rather than moving from northwest to southeast, they start literally moving from west to east, north west to southeast के बदले they start moving from west to east. This is known as west wind drift. It is not possible in the northern hemisphere because land masses. Getting it? Ocean currents. कौन सा? तो सरफेस विंड की कहाँ बात कर रहा हूँ मैं? हाँ, मैं साउथ वेस्ट मानसून विंड पड़ा ही नहीं रहा हूँ, हम ईस्टर्ली जेट स्ट्रीम कर रहे हैं जो सब सरफेस। हाँ, ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम क्या करती है? Surface winds in India are in the form of Arabian Sea branch, southwest monsoon, and the Bay of Bengal branch. Fine. Tropical easterly jet stream ऐसे blow कर रही है over India after originating from the Tibetan plateau. It is flowing with very high speed, and because of this, frictional force will be applicable. Due to frictional force, ये जो साउथ वेस्ट मानसून की winds है, ये भी मूव करेंगी in the direction of the jet stream, and ये देगी rainfall. So हम क्या लिखते हैं? Tropical easterly monsoon plays very important. Tropical easterly jet stream plays very important role in Indian monsoon because it deflects the Bay of Bengal branch into mainland India. बारिश कौन दे रहा है? फाइन, डोंट वरी अगर पता नहीं है. सो जियोस्ट्रॉफिक विंड्स, geostrophic winds. The winds that flow parallel to the isobars, unlike the regular winds, the winds that flow parallel to the isobars, unlike the regular winds, are known as geostrophic winds. These winds are generated, are known as geostrophic winds. These winds are generated due to balancing of pressure gradient force and Coriolis force which occurs due to absence of frictional force, full stop. It generally occurs in geostrophic layer. It generally occurs in the geostrophic layer, which is between the height of, or which is above the height of, not between, above the height of 1000 meters from the ground. Means above the height of 1 kilometers, 1000 meters from the ground, which is above the height of 1000 meters from the ground. Next point. Understanding? Next point. As per the Bay-Ballett's law, कंसेप्ट समझ में आया? ये वर्डिंग छोड़ो, कंसेप्ट समझ में आया? अब हमें सिर्फ एक चीजें लिखनी है as per the optional point of view, as according to the Bay-Ballett's law. According to the Bay-Ballett's law, in the northern hemisphere, if you stand with back towards the wind, if you stand with back towards the winds, then there will be low pressure on your, if you stand with, in the northern hemisphere, if you stand like this, ये है bivalent, if you stand like this, with your back, पीछे से wind आ रही है, there will be low pressure to my right hand side or to my left hand side. What does the Coriolis force say? Deflection कहाँ पे ज़्यादा होगा? Right or left in the northern hemisphere? So, high pressure मेरे right hand side, low pressure मेरे left hand side में, because winds are getting deflected to the right. So कोई भी अगर imagine करो, कोई भी पीछे से wind आ रही है, because it is going to get deflected to the right, there will be high pressure wind जहाँ आ रही है to my right hand side and low pressure to my left hand side, and vice versa in the southern hemisphere. If you stand like this, because with your back towards the wind, they will get deflected to the left. So यहाँ पे high pressure होगा, यहाँ पे there will be low pressure. He is the first person who gave this law, fine, and इस law को फिर prove किया Coriolis ने, जिसको हम कहते हैं Coriolis effect, fine, but do not try this outside. ऐसे कोई फर्क नहीं पता चलेगा. If you, क्या था? There will be low pressure back towards the wind. There will be low pressure. There will be low pressure on the left and high pressure on the right. And the condition is reversed in the southern hemisphere. And the condition is reversed in the southern hemisphere. Condition is reversed in the southern hemisphere. But this law applies only to the airflow near the Earth's surface. This law applies only to the airflow near the Earth's surface due to the three effects. Due to the three effects. Due to the three forces. Due to the three forces. In the upper atmosphere, as the speed of the wind increases, frictional force is absent. Frictional force is absent, and therefore the deflection of the winds increase, with the increase in the deflection, the speed of the winds increase, not deflection, the speed of the winds increase. With the increase in the speed, the deflection increases. And it becomes so significant. That the Coriolis force starts acting opposite to the pressure gradient force. Coriolis force starts acting opposite to the pressure gradient force. Starts acting opposite to the pressure gradient force. And balancing, and these forces start balancing each other. These forces start balancing each other. Because of this, the atmospheric circulation becomes geostrophic. The atmospheric circulation becomes geostrophic. Which means the winds start flowing parallel to the isobars. Winds start flowing parallel to the isobars. You can draw this diagram. समझ में आया डायग्राम? नीचे फ्रिक्शन है, विंड का कोई डायरेक्शन नहीं, डिपेंड्स अपॉन द माउंटेन्स, वैली ब्रीज, ये ब्रीज, बाद में क्लाउड लेयर है, एंड ऊपर आफ्टर 1 किलोमीटर जितना हम ऊपर जाएंगे टिल द ट्रोपोपॉज फ्रिक्शनल इफेक्ट कम होते जाएगा, एंड देयरफॉर जियोस्ट्रॉफिक लेयर विल स्टार्ट. Can I continue? Example, jet streams. Example, jet streams. And therefore, jet streams generally flow from east to west. Example, jet streams generally flow from east to west. In the in the in the case of monsoon in the form of tropical easterly jet, in the case of monsoon in the form of tropical easterly jet, but the flow of other jet streams, is west to east. Flow of the other jet streams is west to east. Flow of the other jet stream is west to east. Next. Geostrophic winds are also present on the surface. When the pressure gradient force is great, and the frictional force is less, This happens in the southern oceans due to the absence of land masses. This happens in the southern oceans due to the absence of land masses. Resulting into formation of west wind drift, Conclusion. Thus the final direction of the wind is always an outcome of relationship between the three forces. And the amount of the forces that are acting depends upon the surface conditions or surface layer. और ये final diagram. This is the most important diagram. And you can see the difference in the values. Is the pressure gradient force greater? No. But यहाँ पे therefore speed increase हो रहा है, deflection increase हो रहा है, and ultimately it is becoming a geostrophic wind. हमने सेंट्रीफ्यूगल फोर्स लिखा है ना, सेंट्रीपिटल नहीं लिखा है, राइट? कोई नहीं, आंसर थोड़ा चेंज हो जाएगा, बट विल कीप द ओल्ड ओनली, फिर से रब नहीं करेंगे नोट्स में, इट डज नॉट मैटर. बिकॉज सेंट्रीफ्यूगल सेंट्रीपिटल फोर्स दोनों बैलेंस करते हैं एक दूसरे को, सो यू कैन राइट द आंसर एनीथिंग. Understood this concept? You don't have to remember this values also. आपको सिर्फ दिखना है कि हमने कितना डिफरेंस दिया है. यहाँ पे डिफरेंस कम होना चाहिए, यहाँ पे डिफरेंस ज़्यादा होना चाहिए. इसीलिए स्पीड बढ़ रही है, स्पीड के साथ डिफ्लेक्शन, डिफ्लेक्शन के साथ कोरियोलिस फोर्स का डायरेक्शन. कंसेप्ट्स याद रखो. फाइन. नाउ ओपन पेज 121 हियर. You'll see 3 cells. In the northern hemisphere. Fine. So जहाँ jet लिखा है, you see the height of the Hadley cell, is it greater than the दूसरा front वाला cell? किसकी height ज़्यादा है? Hadley cell की height ज़्यादा है as compared to the front वाला cell. And front वाले cell की height is greater than the polar वाला cell. जितनी greater is the height, उतना lesser is the temperature. जितना lesser is the temperature, उतना denser is the air. Fine. So what happens in this diagram? Take it in the northern hemisphere. I'll show here. So इसका height is greater as compared to this height, and इसका height is the least. The diagram is like this. So because of the greater height, this is more colder, that means high pressure. This is more warmer, that means low pressure. दोनों का comparison. This is more colder, high pressure. This is more warmer, low pressure. And as a result of this, wind will start flowing from high to low, high to low. But is it geostrophic or surface winds? Is it above the geostrophic layer or is it at the surface layer? This is the geostrophic layer. This is the surface of the earth. Fine. This is tropopause, geostrophic layer. And इसीलिए जो wind high to low जा रही है, equator, it starts moving from, it starts getting deflected to the right. इसका right is this direction, and it moves here. And this is what is known as subtropical westerly jet stream. This air starts moving, and it gets deflected to the right, and this is what is known as polar jet stream. Understanding? This is why the jet streams are generated. Understanding? Similarly, high comparatively low, comparatively more low. This is more high. इन दोनों के बीच का डिफरेंस, बिटवीन टू एयर मासेस, नॉट इन दोनों के बीच का डिफरेंस, जहाँ पे विंड है, जहाँ पे नहीं है वहाँ पे इट स्टार्ट्स मूविंग हियर, इट स्टार्ट्स मूविंग हियर, the direction I am facing you, it will get deflected to the left. Subtropical westerly jet. Polar westerly jet. Except जो तिब्बत से इक्वेटर की तरफ आती है, इट विल गेट डिफ्लेक्टेड टू द राइट. सोमाली और ट्रॉपिकल ईस्टर्ली जेट. गेटिंग इट? These are the three jet streams. Jet streams बहुत आसान है once you understand the three cellular model. Geostrophic wind समझ में आया? Jet streams कुछ भी नहीं है, but it's very easy then. Never in the straight line, ऊपर नीचे, because winds blow कर रही है. कुछ winds इस side नीचे आ रही है, it is getting deflected to the south. Some winds are trying to go to the north. वेस्टर्लीज जहाँ डोमिनेंट है ऊपर की तरफ पुश हो रहा है, ईस्टर्लीज जहाँ डोमिनेंट है नीचे की तरफ पुश हो रहा है. द जेट स्ट्रीम विच इज जनरेटेड बेसिकली इज द पोलर जेट स्ट्रीम. वो इतना ज्यादा मियांडर करती है कि इट ब्रेक्स लाइक ऑक्सबो लेक इनटू डिफरेंट चैनल्स. सो द सदर्न चैनल ऑफ दिस मियांडरिंग जेट स्ट्रीम, देयर इज ओनली वन जेट स्ट्रीम, याद रखना. आई विल कम टू दैट इन द जेट स्ट्रीम. It starts as a polar jet. Then, due to mixing of air mass, it starts meandering. It meanders to such an extent कि ये break हो जाता है in two parts. Break होने के बाद नीचे का part बन जाता है subtropical westerly jet, ऊपर का part बन जाता है polar jet. Nothing but geomorphology वाला ही concept. There is so much meandering कि ऑक्सबो लेक फॉर्म होते हैं, नए channels बन जाते हैं. So यहाँ पे jet streams mix हो जाती है और दो jet streams develop होती है. So always the most powerful jet stream will be polar jet stream. And when it comes to the south, ये जो ऊपर, just imagine 3 dimension में ऊपर जब वो ऐसे meander कर रही है, जब वो बहुत ज़्यादा meander करती है and comes to the south, that is known as polar vortex. At least understanding? Not? Why it is meandering, have you understood? What you have not understood then? What you have not understood then? Meander क्यों कर रही है पता चला है? Any other doubt? मतलब ज़्यादा I will not. I will go step by step only. Geostrophic wind सबको समझ में आया? I was trying to connect and make subsequent lectures easy for you, but you got confused. Six to 12 kilometers के height. Yes. Because jet stream का thickness is around 4 to 5 kilometers thick. उसका upper part is at 12 kilometers, lower part is at 6 kilometers. नहीं नहीं, understand, this is the normal jet stream, 6 to 12 kilometers. Tropical easterly jet stream starts at 6 kilometers. बाकी के jet stream कौन से किलोमीटर पे start होती है? 12 kilometers में, ऊपर का part. Tropical easterly jet stream जो blue color की है, उसकी height is 6 kilometers. मतलब वो नीचे कहाँ तक आएगी? एटलीस्ट 5 किलोमीटर थिक है तो कहाँ तक आएगी वो? 1 किलोमीटर तक. जैसे ही 1 किलोमीटर पे आएगी, इट कम्स इन द फ्रिक्शनल लेयर. एंड जैसे ही वो फ्रिक्शनल लेयर पे आएगी तो वो सरफेस विंड्स का डायरेक्शन चेंज करेगी. बाकी की विंड्स की थिकनेस यहाँ तक होती है जेट स्ट्रीम्स की. ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम की थिकनेस यहाँ से यहाँ तक होती है. अब ये जा रही है विथ हाई स्पीड, तो साथ साथ नीचे की सरफेस विंड्स को लेके जा रही है. That is the reason why it affects the monsoon winds. बाकी किसी climate में क्यों नहीं affect करता? It is just because of, imagine a simple condition कि flight बहुत ऊपर से जा रहा है, कुछ फर्क नहीं पड़ेगा. Flight आपके एकदम नज़दीक से गया, वो drag, air drag लेके जाएगा. That is nothing, air drag. Because jet stream का velocity is 600 kilometers per hour. So air drag तो होगा ही. ट्रेड विंड्स कहाँ पे होती है? ट्रेड विंड्स कहाँ पे होती है? ट्रॉपिक्स में. कहाँ से कौन से लैटिट्यूड से कौन से लैटिट्यूड तक? 5 to 35 डे. सरफेस पे है, सब सरफेस है? सरफेस है. एंड नाउ आस्क द क्वेश्चन अगेन यू आर आस्किंग. हाउ कैन वेस्ट विंड ड्रिफ्ट विच इज अ जियोस्ट्रॉफिक बी अ ट्रेड विंड? वेस्ट विंड ड्रिफ्ट कहाँ पे है? अंटार्कटिक के पास है. वहाँ पे जाएगी ट्रेड विंड? वहाँ पे ट्रेड है, वेस्टर्लीज है. Surface winds are not forming anything. Surface wind, westerly is forming west wind drift. What is wind? Hadley cell क्यों बन रहा है? But wind का नहीं, air का. Air movement in tropics, wind नहीं. Question अगर आता है wind in tropics, you will write trade winds, equator westerlies. अगर आता है क्वेश्चन एयर मूवमेंट इन ट्रॉपिक्स, यू विल राइट हैडली सेल. सो इफ यू आर कंफ्यूज बिटवीन विंड एंड एयर, लिखोगे कुछ भी, मार्क्स 0 मिलेंगे. डोंट, विंड इज विंड, एयर इज एयर. विंड का कभी कन्वेक्शन नहीं होता है, एयर का कन्वेक्शन होगा. यही मैं बताने की कोशिश कर रहा हूँ. डोंट बी कैजुअल इन द अप्रोच. एयर का कन्वेक्शन होगा, विंड का कभी नहीं होगा. एयर का कन्वेक्शन इज फ्रॉम लो प्रेशर टू हाई प्रेशर, विंड फ्लोज फ्रॉम हाई प्रेशर टू लो प्रेशर. Getting it? क्योंकि ये when you are not very specific, प्रॉब्लम ये हो जाता है, then in the exam you get confused और आंसर्स गलत लिख के आते हो और फिर ऑप्शनल को ब्लेम करते हो. फाइन. सूडो वॉल्केनिक फीचर पूछते हैं, आप लिख के आते हो अगर वेरी गुड आंसर ऑन वॉल्केनिज्म, और बोलते हैं ज्योग्राफी ऑप्शनल कभी मार्क्स नहीं देता. एयर मूवमेंट इन ट्रॉपिक्स पूछेंगे, आप लिखोगे ट्रेड विंड्स और फिर कहोगे ज्योग्राफी ऑप्शनल मार्क्स नहीं देता, मैंने तो बहुत अच्छा आंसर लिखा था. एयर इज एयर, विंड इज विंड. सो व्हाट इज अ जियोस्ट्रॉफिक विंड? टेल मी इन द टर्म्स ऑफ साइंस. फोर्सेस, 2 फोर्सेस है, तीसरा फोर्स एब्सेंट है. कौन सा फोर्स एब्सेंट है? फ्रिक्शनल फोर्स. व्हाट इज अ ग्रेडियंट विंड? जब 3 फोर्सेस प्रेजेंट है. प्रेशर ग्रेडियंट फोर्स, कोरियोलिस फोर्स एंड आंसर कैन बी एनीथिंग. इंडियन बुक्स जो है, फॉर एग्जाम्पल इफ यू आर रीड सविंद्र सिंह, he has taken the help of centrifugal force. If you are reading what book? Rupa, he has taken the help of centripetal force. मेरे पिछले साल के नोट्स में सेंट्रीपिटल है, आज मैं सेंट्रीफ्यूगल बताऊंगा, because we have written already the centrifugal force. Because on any rotating object, both these forces are equal and opposite. They try to balance each other. So कोई फर्क नहीं पड़ता. Right? So इससे कोई फर्क नहीं पड़ता. बट कहाँ पे होगा? इन द रीजन्स. कहाँ पे होंगे ये 3 फोर्सेस? फ्रिक्शनल फोर्स इतना मिनिमल हो जाता है बिकॉज विंड का स्पीड इतना ज्यादा है कि फ्रिक्शनल फोर्स इज नॉट अफेक्टिंग. दिस विल ऑलवेज ऑकर इन द रीजन्स जहाँ पे देयर इज अ क्लोज्ड आइसोबार्स. द ओनली डिफरेंस इज व्हेन वी आर डूइंग सेंट्रीपिटल फोर्स, हम इस डायरेक्शन में एरो बनाते हैं, अब हमें एरो बाहर की तरफ बनाना है सेंट्रीफ्यूगल फोर्स में. फाइन. So this isobars are known as closed isobars. gradient wind, and how the questions will be direct questions. Write a short note on the gradient wind. Write a short note on geostrophic winds. There won't be indirect questions in this part. When the wind moves along the closed isobars, when the wind moves along the closed isobars with very high velocity. So very high velocity, matlab which force has become minimum? Frictional force. The force due to pressure gradient, the force due to pressure gradient is balanced by deflective force, matlab Coriolis force, and centrifugal force, then such wind is known as gradient wind. Such wind is known as gradient wind. The centrifugal force is always equal in magnitude, but opposite in direction to centripetal force. Magnitude strength में equal है, but opposite in direction to the centripetal force. वही जो मैंने वॉशिंग मशीन का एग्जाम्पल लिया था, to the centripetal force. Equal in magnitude but opposite in direction to the centripetal force. इस लाइन से जो भी confusion है निकल जाएगा. Getting it? Next. देखो, before I proceed again, नॉर्मल विंड्स में 3 फोर्स बैलेंस कर रहे हैं एक दूसरे को. कौन से? कोरियोलिस, प्रेशर ग्रेडियंट एंड फ्रिक्शनल. दैट इज अ नॉर्मल विंड. जियोस्ट्रॉफिक विंड में सिर्फ 2 ही फोर्स बैलेंस कर रहे हैं, प्रेशर ग्रेडियंट एंड कोरियोलिस फोर्स. यहाँ पे भी 3 फोर्स ग्रेडियंट विंड में, बट दैट इज इधर सेंट्रीफ्यूगल और सेंट्रीपिटल, प्रेशर ग्रेडियंट एंड कोरियोलिस. बस दिस इज ऑल अबाउट द विंड्स. नेक्स्ट. Therefore, such wind is generated around high pressure or low pressure centers. Such wind is generated around high pressure or low pressure centers. Is generated around the high pressure or low pressure centers. That is around anticyclones and cyclones. Around anticyclones and cyclones. Theoretically, a wind always flows in a straight line due to the pressure gradient force. Theory के लिए, theory wise, always flows in a straight line due to the pressure gradient force. But in reality, as soon as the motion begins, but in reality, as soon as the motion begins, the wind starts getting deflected, due to the Coriolis force. Starts getting deflected due to the Coriolis force. If the motion is around, curved isobars or closed isobars is around the curved isobars, then following conditions may exist. Following conditions may exist. Condition 1. In which direction is the pressure gradient force applied? From high to low. Don't draw anything, पहले समझना. Right? In which direction is the centrifugal force getting applied? Away from the center. Coriolis force to the right hand side. So wind आ रही है, it is going to get deflected to the right hand side. Fine? In the northern hemisphere. It is going to get deflected to the right hand side in the northern hemisphere. It is going to get deflected to the right hand side in the northern hemisphere. To the right hand side in the northern hemisphere. Getting it? But due to the pressure gradient force, ये अंदर की तरफ भी जाएगी. Depend करेगा कौन सा force ज़्यादा stronger है. Fine? ऐसे जैसे ही अंदर की तरफ जाने लग गई, that is, as soon as it is going inside, the centrifugal force will try to pull it away. So as a result of this, there will be a situation when centrifugal force will start balancing the pressure gradient force. मैंने एक लाइन लिखवाई है, centrifugal force is always equal and opposite to the centripetal force. यहाँ पे is the pressure gradient force behaving like a centripetal force? Right? So these two forces will start balancing each other. As these two forces will start balancing each other, so ultimately the direction of the wind will be such that ये बीच में जाएगी. इस सर्कल के अंदर की विंड ऐसे जाएगी. इस सर्कल के अंदर की विंड ऐसे जाएगी. And therefore we say in the northern hemisphere cyclones move in anti-clockwise direction. In the southern hemisphere, left, pulled inside. But then once it is balanced, it will start moving in a clockwise manner. What is the general diagram for cyclones? Low pressure, high pressure. In the northern hemisphere, anti-clockwise, low pressure, high pressure. In the southern hemisphere, clockwise. This is theoretical representation, this is reality. Getting it? This is how cyclone is moving. ये simplified diagram है, ये है reality. अब imagine करो anti-cyclones में, just imagine करो. ये है high pressure, ये है low pressure. So pressure gradient force is here. Coriolis force is here. Why? Because frictional force both cyclones and anticyclones में बहुत कम है. First statement में ही हो गया. with very high velocity. So Coriolis force will act as a centripetal force, and pressure gradient force will act as a centrifugal force, and therefore wind ऐसे, that is they will start moving clockwise. I will show you there. But have you understood this? Wind is coming and it is going to get deflected here, but once this forces start balancing, वो ऐसे जाएगा. If the pressure gradient force is more, वो अंदर की तरफ खींचा जाएगा. It will start balancing, वो अंदर की तरफ खींचा जाएगा. It will start balancing, वो अंदर की तरफ खींचा जाएगा. And thus हमें लगेगा it is moving in a anti-clockwise manner. पहले हम लिख लेंगे, फिर आपको एक एनिमेशन दिखा के you can make this diagram first. I'll explain you, but first make the diagram. Make the diagram the way I am making now. Gradient wind, if you can understand little bit basics diagram को देख के, is a special case of geostrophic wind. Am I right or wrong? The only thing is यहाँ पे तीन forces में से दो forces इकट्ठा हो रहे हैं and they try to balance pressure gradient force. यहाँ पे the centrifugal force and the Coriolis force are trying to balance the pressure gradient force. You have to make only that diagram and this connotation, ये नहीं. That is why winds are deflecting inside. What is a cyclone? Low pressure center. Otherwise the winds would have flown parallel. Why they are going inside? Understanding? This is the same diagram we have drawn. Which is more powerful? PGF. Therefore, winds are being forced to come inside. सारी winds कैसे जा रही है? अंदर की तरफ. यहाँ पे भी. Obviously, Coriolis force and the centrifugal force is trying to balance. But PGF को साथ मिल जाता है. हमेशा अगर centrifugal force है there, तो centripetal force will be saying, मैं भी हूँ, I'll be acting opposite. So PGF plus centripetal force is acting, and फिर Coriolis force and centrifugal force का ताकत इतना नहीं रह जाता है, because इनका गठबंधन strong हो जाता है. You can say there what coalition becomes stronger. So in the end, winds will be pulled towards this low pressure center. Anti-clockwise, proper. Only thing is we cannot show this in the diagram. We show it this way. This is what is the gradient wind. Coriolis force, pressure gradient force, Coriolis force लेफ्ट की तरफ खींचेगा. फाइन. प्रेशर ग्रेडियंट फोर्स अंदर की तरफ खींचेगा. Coriolis force को साथ में लेगी ऑफ द सेंट्रीफ्यूगल फोर्स. प्रेशर ग्रेडियंट फोर्स को साथ में लेगी सेंट्रीपिटल फोर्स की. सो ये लेफ्ट की तरफ ना जाते हुए विल गो इनसाइड सदर्न हेमिस्फीयर. दैट इज एग्जैक्टली अवर डायग्राम में थिंग्स विल चेंज. Because Coriolis force is changing the direction. यहाँ पे Coriolis force is pulling it in this direction. Pressure gradient force is pulling it in this direction. अगर ये southern hemisphere होता तो Coriolis force would have pulled it in the exactly opposite direction. That is, it would have pulled it in this direction. So यहाँ तक राइट में शिफ्ट हो रहा है. अगर यहाँ पे लेफ्ट में शिफ्ट होता तो क्लॉकवाइज हो जाता. दैट इज सदर्न हेमिस्फीयर. यहाँ पे राइट में शिफ्ट हो रहा है इसलिए एंटी क्लॉकवाइज हो रहा है. PGF will apply यहाँ तक gradient wind का region is only this, बाकी this में normal force is getting applied, so it is going to right, and then एक बार अंदर जाने के बाद maximum, yes, PGF. That is why we say ट्रॉपिकल साइक्लोन, जीएस में हम क्या लिखते हैं, आर लो प्रेशर सेंटर्स, हम बाकी फोर्सेस की बात ही नहीं करते, जो मोस्ट इंपॉर्टेंट फोर्स है वही लिखते हैं हम. एंटी साइक्लोन्स आर हाई प्रेशर सेंटर्स, सो मोस्ट इंपॉर्टेंट फोर्स इज ऑलवेज प्रेशर ग्रेडियंट फोर्स. अंडरस्टूड दिस? नहीं समझ में आया? सो डाउट? Same. PGF becomes so strong कि velocity increases because velocity is determined by pressure gradient, difference in the high pressure and low pressure. Velocity अगर ज़्यादा हो गई तो कोई भी surface हो दो, frictional force गायब हो जाता है. and फिर यही, चाहे वो land पे होने दो, चाहे वो समंदर पे होने दो. so इसलिए first line थी velocity. If you look at the top, first paragraph में ही velocity है. Got it? A wind moving along the isobars with such a high velocity, that is the first condition. अगर velocity कम हो गई तो फिर ये सब गड़बड़, फिर तो wind को कोई direction ही नहीं रहेगा, because frictional force अब इसको किसी और direction में खींचेगा. इसलिए लैंड पे अगर आपने ये देखा होगा, समथिंग लाइक साइक्लोन, जिसको हम कहेंगे आंधी या भौरा, वो आता है डिसअपियर होता है, आता है डिसअपियर होता है, और फ्रिक्शनल फोर्स थोड़ा ज़्यादा है लैंड पे, इसलिए उसको कोई डायरेक्शन नहीं होता, कभी इस डायरेक्शन में जाएगा, कभी इस डायरेक्शन में जाएगा. ओशंस पे फ्रिक्शनल फोर्स कम है, इसलिए ट्रॉपिकल साइक्लोन्स मूव फ्रॉम ईस्ट टू वेस्ट. गेटिंग इट? देयर इज अ स्पेसिफिक डायरेक्शन इन ओशंस. So next point, in the low pressure centers, condition 1, that is in the low, condition 1 is cyclones, low pressure centers. किसका डायग्राम है? लो प्रेशर सेंटर का ही. So that is the condition 1 in the low pressure center. Pressure gradient force is more powerful. Pressure gradient force is more powerful. The lowest pressure is always at the center of, is always at the innermost isobar. ये एग्जाम में लिखने की जरूरत नहीं, ये आपको समझने के लिए. The lowest pressure is always at the innermost isobar. The Coriolis force is directed outwards. The Coriolis force is directed outwards. And hence the net difference, and hence the net force, not the difference, net force that is applied, that is being applied on the winds, that force that is applied to the wind theoretically net force कितना होना चाहिए? Theoretically, see, theory wise, this should be equal to this. These two forces, pressure gradient force plus centrifugal force, should be equal to this. But the net force that is applied, because this is stronger, will be more. कहाँ पे? Outwards या inwards? inwards. Therefore, the net force will be directed inwards. Directed inwards. And hence the wind will start blowing in the anti-clockwise direction. Parallel to the circular isobars. Anti-clockwise direction. Parallel to the circular isobars. Before entering the low pressure system. Before entering the low pressure system. While in the southern hemisphere, as the Coriolis force deflects the winds to the left, the pressure gradient force will pull the winds inwards. कौन सा फोर्स ज्यादा है? अंदर वाला. Fine. And therefore winds will start flowing. Winds will start flowing in a clockwise manner. Wind will start flowing in the clockwise manner. Fine. This is a very simplified diagram. ये दो डायग्राम बनाने की जरूरत नहीं, बिकॉज यहाँ पे कोरियोलिस फोर्स बाहर अंदर की अपोजिट डायरेक्शन में अप्लाई कर रहा है यहाँ से. सो ये ऐसे जाने के बदले दे विल बी पुल्ड इनसाइड. यहाँ पे वो ऐसे जा रहे हैं राइट में, देयरफॉर दे आर गेटिंग पुल्ड इनसाइड फ्रॉम. दैट इज अ प्रेशर ग्राउंड कंडीशन. इट हैज नथिंग टू डू विद द कोरियोलिस फोर्स एक्सेट्रा. दैट इज अ टेम्परेचर कंडीशन. I in the center is because this is so hot that is winds go inside and rise from here. Winds होगी descending. Winds होगी descending. कोई टी सीरीज का क्वेश्चन सॉल्व कर रहे थे? Next, see, his question is why there is I. That has to do with ये प्रॉपर डायग्राम है जोग्राफिकली. अंडरस्टैंडिंग? आइसोबार, आइसोबार, आइसोबार. यहाँ पे there is so much heat, that is wind which is coming up is rising from here. It is rising from here, and therefore the center part में there is an I. The wind which rises from here due to convection is thrown, and therefore ये ऐसे cloud बन गया. ऐसे बैंड्स क्या है? नथिंग बट आइसोबार्स. दिस इज अ साइड व्यू, दिस इज टॉप व्यू. कंडीशन 2. in the anticyclonic circulation, the pressure gradient or the pressure difference between the high pressure and low pressure is not great. The pressure difference or the pressure gradient between the high pressure and low pressure system is not much or bigger or greater. मतलब कौन सा फोर्स वीक है इन एंटीसाइक्लोनिक? प्रेशर ग्रेडियंट. कौन सा फोर्स स्ट्रांग होगा फिर? कोरियोलिस. एंड इसीलिए एंटीसाइक्लोन्स में किसी को कंफ्यूजन नहीं आता इवन इन जीएस. एंटीसाइक्लोन्स हाई प्रेशर सेंटर, बाहर लो प्रेशर, दिस इज हाई, दिस इज लो, लो 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 लो, फाइन. एंड देन डायग्राम इज वेरी सिंपल. प्रेशर ग्रेडियंट फोर्स इतना ज़्यादा नहीं है, कोरियोलिस फोर्स ज़्यादा है. देयरफॉर एंटी साइक्लोन्स में हाई प्रेशर टू लो प्रेशर, दे विल गेट डिफ्लेक्टेड टू द राइट. दे विल गेट डिफ्लेक्टेड टू द राइट. हम क्या करते हैं जीएस में? एंटी साइक्लोन्स आर क्लॉकवाइज इन द नॉर्दर्न हेमिस्फीयर एंड सदर्न हेमिस्फीयर में दे आर एंटी क्लॉकवाइज. अंडरस्टैंडिंग? खेल सब किसका है? किसकी ताकत ज्यादा है? प्रेशर ग्रेडियंट की ज्यादा है साइक्लोन्स में, कोरियोलिस की ज्यादा है एंटी साइक्लोन्स में. सो यहाँ पे प्रॉपरली कोरियोलिस इफेक्ट दिखता है, यहाँ पे प्रेशर ग्रेडियंट का इफेक्ट दिखता है. Anticyclones, if the pressure gradient is less as compared to the Coriolis force is less as compared to the Coriolis force, PGF is less as compared to cyclones. Now see, this is all relative. यहाँ पे PGF is more stronger, Coriolis force is not the dominant force. यहाँ पे PGF is very less, therefore Coriolis effect becomes dominant. ऐसा नहीं है. That is what I said in day before yesterday's lecture. Coriolis is not a force, it is an effect. Anticyclones में remember GS, what we say? Anticyclones move with very slow speed, 10 to 15 kilometers per hour. Why? Because speed is different. I am coming to your question only. Speed is determined by the pressure gradient force. Cyclones में the wind speed is 300 to 400 kilometers per hour. That shows that the pressure gradient is greater. Because the pressure gradient is greater, Coriolis effect is not seen properly. Winds behave, wind का final direction will not always be determined by the Coriolis force. I am coming to his doubt only. Suppose this is an high pressure in the northern hemisphere, this is a low pressure. Wind will always flow from high pressure to low pressure and it will get deflected to the right. But a new low pressure system develops due to some extent. And this low pressure system is very, very strong. Then wind will not follow the Coriolis effect. It will start moving this way and it will get deflected to the right. Getting it? Now coming to anticyclones, literally it does not mean that Coriolis effect force is more, because Coriolis is not a force in itself. It means because the pressure gradient force is comparatively less, deflection ka effect is more dominantly seen, and we write in simple words that Coriolis force is greater. Understanding? It does not mean that Coriolis force is greater. It means when the pressure gradient force is not as great, then winds follow the normal rule of deflection to the right or deflection to the left, as what is seen here, nothing else. Many people now got confused. This was the same doubt you are asking? Less. Yes. But deflection will be there in any case. You are anticyclones may is the low pressure at the center or low pressure is outside. So centripetal force will be dominant or centrifugal force will be dominant? Centrifugal force. So pressure gradient force, centrifugal force will be dominant. That is outside the force will be more dominant. Therefore wind in any case will be going outside. And because pressure gradient force is less, so the deflection will be, even if the wind is moving with normal speed, the deflection can be seen to the normal eyes. And therefore we say that Coriolis effect is more. Coriolis force does not change in magnitude. I will come to your point. First you write down. This all doubts arise when you take Coriolis force as a force. It is not a force, it is an effect. Fine? That is the biggest confusion which science has created by giving it a name force. Coriolis is an effect. It is not at all a force. And because it is not at all a force, it does not have vector and magnitude. मुझे physics में जाना पड़ेगा. But your doubts will get resolved. वो मुझे फिजिक्स में मत लेके जाओ. फोर्स इसलिए नहीं है. ये सब डाउट 5 मिनट में क्लियर हो जाएंगे. When I'll explain you in simple language once we finish this. Where was I? Force is not greater. The pressure gradient force is not greater. And therefore, the Coriolis effect, which is directed inwards, is slightly greater than the outward directed pressure gradient force. Outward directed pressure gradient force. Read that line again and tell me what does it mean. It means pressure gradient force is acting here. Because these winds do not have frictional force, uske opposite direction mein Coriolis force will be acting. Wind will start flowing. Now you will understand your doubt. Wind will start flowing from high pressure to the low pressure. Fine. But कौन सा ज़्यादा effective है? Coriolis force, which is pulling downwards. Therefore, winds बाहर की तरफ नहीं जाएगी. Winds ऐसे जाएगी. विंड्स बाहर की तरफ नहीं जाएगी, विंड ऐसे जाएगी. It will be directed inwards. And we say anticyclones are clockwise in the northern hemisphere. This is what it means. Is your doubt clear now or not? Have you understood this concept or not? Forget about your doubts. Can you write an answer? Bas. Why the Coriolis force का line is thick? Because the effect is more dominantly seen. पहले केस में प्रेशर ग्रेडियंट अंदर की तरफ था तो कोरियोलिस बाहर की तरफ था. चलो वो छोड़ो, ग्रेटेस्ट स्मॉलेस्ट वाला. पहले के केस में प्रेशर ग्रेडियंट अंदर की तरफ था तो कोरियोलिस बाहर की तरफ था, तो विंड कैसे जाती थी? एंटी क्लॉकवाइज. यहाँ के केस में प्रेशर ग्रेडियंट बाहर की तरफ है तो कोरियोलिस अंदर की तरफ है, तो फिर विंड ऐसे जाने के बदले वो राइट की तरफ मुड़ रही है. वहां पे विंड अंदर आने के बदले वो राइट की तरफ मुड़ रही थी. बस यही है. See, theoretically, centrifugal force and centripetal force are balancing each other. In reality, centrifugal force and centripetal force में हमेशा difference रहेगा. Real life is different. Theoretics is different. अगर centrifugal force and centripetal force को हम balance कर पाते exactly, तो कपड़े मशीन के बीच में spin होते. जब centrifugal force ज़्यादा है तो बाहर की तरफ खींचे जाते हैं. सेंट्रीपिटल फोर्स जब ज़्यादा है तो अंदर की तरफ खींचे जाते हैं. इसलिए कपड़े धुलते हैं. अगर आपने बैलेंस किया तो कपड़े ऐसे सेंटर में ऐसे गोल 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 घूमते. So reality is this. Anticyclones में comparatively this force is weaker. Cyclones में comparatively the pressure gradient force is stronger. It also depends upon speed of the wind. See, यहाँ पे speed भी कम है. See, coming to again, ये समझ में आया? ये समझ में आया? In the first case scenario, this was the pressure gradient force was acting. Because frictional force is not there, this is the Coriolis force which is acting. Fine? In the northern hemisphere, they will get deflected to the right of the direction. So, right, they will try to balance each other. और हमें लगेगा which direction? Anti-clockwise. Fine? ये समझ में आया? This is यही लिखना है एग्जाम. Even if you forget one, two, these things. In the southern hemisphere, pressure gradient force is acting here. Coriolis force is acting always parallel, but वो deflect करेगा to the left. And therefore, cyclones are clockwise. In this case, Coriolis force is acting inwards because the pressure gradient force is acting outwards. So it will get deflected to the right. Had this been southern hemisphere, Coriolis force is acting inwards, pressure gradient force is acting outwards. So southern hemisphere mein they would have got deflected to the left, and we would have written anticyclones are anti-clockwise in the southern hemisphere. Is it clear now? ये इतना simple concept है. Forget कौन सा ज़्यादा है, forget कौन सा कम है. जो अंदर की तरफ आ रहा है वो centripetal है. So इसमें Coriolis force is acting as a centripetal force, pressure gradient force is acting as a centrifugal force. Here pressure gradient force is acting as a centripetal force and Coriolis force is acting as a centrifugal force. Bas. In the end, both should balance each other, always. Clear? How many pages have occurred? How many pages gradient wind ka? I guess already 2 pages. Fine. In the exam, obviously, you are not going to write this long. It will come in 150 or 200 words. मतलब जो चीज़ें नहीं समझ में आ रही है, उसको cancel कर दो, लिखना ही क्यों है exam में? What will matter is whether you tell the examiner properly कि direction क्या है wind की, बस. You are not going to write this long. These are notes. These are not answers. Fine? So don't fall in that trap. कि Google it, etc. No. Google वही करो कि जो नहीं समझ में आया, but नहीं समझ में आया वही Google करो. Do only Google those things. That is, if you don't understand anything in the class, ask me. Even if you are not even if you are not convinced, go home, look at the past year paper. If the questions have coming with great frequency, Copen, Thornwhite, then Google it. ऐसे फालतू टॉपिक्स के लिए don't Google it. Fine? Understanding? And save your energy, nothing else. You don't want to be a next teacher of geography. Next point. Where did I stop? So next point. The pressure gradient force and centrifugal force. Pressure gradient force and the centrifugal force will balance the Coriolis force. Will balance the Coriolis force. And therefore, in the northern hemisphere, the circulation is of around the anticyclones is clockwise. And in southern hemisphere it is anti-clockwise. In southern hemisphere it is anti-clockwise. In southern hemisphere it is anti-clockwise. Again I am explaining you for the last time. Pressure gradient force, Coriolis force. Wind always follows the direction of the pressure gradient force, and the Coriolis force will deflect it to the left or right. It will start flowing from high pressure to low pressure, and uske baad it will start getting deflected to the left or right. In the southern hemisphere, left. Pressure gradient force, Coriolis force अंदर, it will start getting reflected to the left. यहाँ पे भी किसी भी point पे, चलो ये point ले लो, pressure gradient force, Coriolis force, it will get deflected to the left. Clear? Clear? Conclusion. Thus, by understanding the gradient wind, we can conclude that cyclonic circulation is anti-clockwise in northern hemisphere and clockwise in southern hemisphere. And anticyclonic circulation will be clockwise in northern hemisphere and anti-clockwise in southern hemisphere. And these are the things you should remember for GS. That's it. And before I forget, कल का Indian Express, there is an article on plastic pollution. पूरा cut that article, उसमें 5 point दिए ही plastic pollution sources, what is single use plastic, should we ban it, recycling, reuse. ये 5 point है आपके answers के, उसके पूरा वो headers या कर लो properly. I'll bring that article tomorrow and tell you what should remember. Secondly, आज का ET explained में, in the today's Indian Express explained, there is direct our optional का question. on the effects of Indian Ocean current in Atlantic Ocean. Effects of एक तो अमेज़न फायर्स पे है एंड दूसरा है अटलांटिक ओशन का करंट्स ऑन द इंडियन ओशन. Is Indian Ocean currents helping Atlantic? And the short note will be directly Atlantic meridional overturning current. So what is that? Has been explained. AMOC. Winds in tropics. Trade winds. I've already told you what is trade winds, I guess, earlier. Winds in subtropics, westerlies. And winds in the polar region is polar easterlies. So if we see this, what is the west trade winds? They blow from the subtropical high pressure belt to the equatorial low pressure belt. And due to that is they should move straight, subtropical high pressure belt to the equatorial low pressure belt. But due to the Coriolis effect, they are deflected to the right in the northern hemisphere. They should move straight, but instead of moving straight, they are deflected to the left in the southern hemisphere. And these winds are known as easterlies or trade winds. Right? They both converge at which zone? ITCZ, Intertropical Convergence Zone. Clear? ITCZ is shifted to the position of the sun. ITCZ is over the Tropic of Cancer during the summer solstice. Date 21st of June. It is over the equator during the equinoxes. Date 23rd of September. What is today's date? And 21st of March. And it is over the southern hemisphere, sun, during 22nd of December. That is winter solstice. Ask yourself, does the sun exactly follow the English calendar? Sun खुद को पूछेगा, today is 23rd of September. I have to be at the tropic of, at the equator. मैं अभी speed बढ़ाता वैसे होगा नहीं. So this is English calendar, and then there are some Eastern calendars, including India. The day when by the Panchang or by any calculation, proper mathematical calculation, position of earth, rotational speed of the earth, etc. Japanese calendar also, मैं ऐसे नहीं कह रहा हूँ, Indian calendar ही. So ऐसा superstition नहीं है. Superstition is astrology. I am talking about astronomy, right? So by this date, equinox will fall on 29th of September because sun ka changes way, and that is why we celebrate every year on the day of equinox Navratra. Navratra signifies the start of equinox and the shifting of sun to the southern hemisphere. 9 days. Why 9 days? Because that is the 9 days when suddenly the climate will keep on changing. And because of the sun going, till the time climate gets adjusted, suddenly there will be rise in the bacterial infections because sun's energy will kill those. Ab sun ka energy is going to reduce. There, because of this transition period between summers and winters, there will be some infections. And isiliye, Navratra mein you do fasting. You should technically do fasting. अब बिना भगवान के डर का कोई फास्ट नहीं करेगा, and thus God is born. Fine? God is also biggest unifier and God is also biggest divider. Fine? Depend करता है आप कैसे use करते हो God की terminology को. Similarly, when the sun comes on 21st of March, that is also Navratra in the North India. That is also the Navratra. So Navratra signifies this thing. Up, India is slightly different because of its position. So sometimes ITCZ, because यहाँ पे there is ocean, यहाँ पे there is a Pacific Ocean, but here there is a land mass. Therefore, ITCZ, instead of being following exactly to the sun, as the land gets heated, ITCZ का shift is more prominent in Asia. Do you agree with me? And because the ITCZ का shift is more prominent in Asia, this becomes a low pressure belt. ITCZ is a low pressure belt. यहाँ पे what should happen? The trade winds of the northern hemisphere, which ideally should go to the equator, but because ITCZ is shifting, the trade winds of the northern hemisphere will come to the ITCZ. अब इंडिया में प्रॉब्लम ये है कि यहाँ पे हिमालयाज है, right? So the trade winds cannot cross the Himalayas because of the height, and the trade winds of the southern hemisphere should also come to the equator. So by the Coriolis force, they deflect through the left, and once they cross the equator, by the Coriolis force, they will get deflected to the right. Getting it? Fine? This winds by a famous geographer, Flon, were known as equatorial westerlies. So, जब भी आप क्वेश्चन आएगा winds in the tropics, if you write only trade winds, you will get half marks because the rest of the half marks will be determined given to the equatorial westerlies. Fine? Winds in the subtropics कभी नहीं पूछा UPSC ने, winds in the polar कभी नहीं पूछा है क्योंकि answer is very straightforward and this is the question that UPSC will ask you. In some last 2 years back, they asked you a short note on equatorial westerlies. Understanding what is equatorial westerlies? Flon ka concept. It was rejected, and once it was rejected, nobody took interest. Came the concept of the southwest monsoon winds, because equatorial westerlies are nothing but the southwest monsoon winds. And then in 1960s, and especially in 1997, something was discovered known as Indian Ocean Dipole. I am not going to teach you Indian Ocean Dipole abhi, but आज ही मैंने GS में पढ़ाया है, and I'll just show you उसका this thing. Chalo, you first, till the time I get used to, yes. When there is a concept of negative Indian Ocean dipole, that is, what is negative Indian Ocean dipole? Dipole means two poles of Indian Ocean. One is the Arabian Sea, one is the pole of around Indonesia, Australia region. Recently, we have understood that during the negative phase of Indian Ocean dipole, Arabian Sea becomes colder. The Indian Ocean becomes warmer. Fine? The eastern part of the Indian Ocean becomes warmer around Indonesia, Australia, and therefore, following the law of wind, high pressure to low pressure, winds rather than coming towards India, flow towards Indonesia. This regenerated the interest in the equatorial westerlies, which come during the negative Indian Ocean dipole phase, which causes droughts in India, but good rainfalls in Indonesia. During the positive Indian Ocean dipole, exactly opposite condition है. ये गर्म है, ये ठंडा है. So winds flow from east to west. They are no longer equatorial westerlies. Fine. This is also Madden-Julian oscillation. It is exactly opposite to the equatorial westerlies. ये गर्म है and therefore यहाँ पे wind ऊपर जा रही है, and ये ठंडा है, therefore wind is coming from high pressure to low pressure. It is going upwards, giving rainfall and good rains over India. Clear with this? Now open the handout I have given you. Come to the first page. We have done all this, so I am not repeating again. The following are the pressure belts, doldrums, trade wind belt, we will do shifting of the pressure belts later on. And come to page number 114. I am reading this. Modern views about the surface wind system, winds in the tropical regions. First, we have already discussed the various aspects of the doldrums, the trade winds, and the so-called anti-trades found within the tropics. Any doubts here? You already know what is doldrums, you already know what is anti-trades. Upper air, westerlies. But the old concepts prevalent regarding this circulation system is not in perfect agreement, XYZ, हमें कुछ करना नहीं है, exam से related नहीं है. During the Second World War, numerous observations were made in the upper air as well as near the earth's surface. If you attended the GS lecture, I commonly tell you during the Second World War, we discovered jet streams. Fine? Because the planes were going from USA to Japan and उनकी speed कम हो गई. Jet stream flew from west to east. Plane going from USA to Japan goes from east to west. Enemies. Fine. So this is why this statement has been given, which brought about the radical change in our views about the tropical circulation pattern. इससे पहले single cell model dominant था, अब tricellular model dominant है. Fine. However, these observations are not sufficient to warrant a formulation of altogether new model of wind system, etc. It is generally believed that the trade winds blow from the constant direction over the oceans, and those prevailing winds from both the hemispheres converge in the vicinity of the equator, where calm prevails, and the afternoon showers from cumulonimbus cloud is a rule than exception. इसका मतलब क्या है? Winds will come, they will converge at ITCZ, and after converging at ITCZ, due to low pressure system, they will rise upwards, and after rising upwards, they will form a special kind of a cloud known as cumulonimbus cloud. No need of writing this or remembering this. This we are going to do in each and every subtopic. Convectional rainfall में यही लिखना है हमें. Fine. So understanding why it is known as ITCZ, just understand the text. But meteorologists discovered that low latitude areas have non-periodic winds most of the time. Non-periodic winds means they are not permanent winds. Violent storms like hurricanes, typhoons form not only in the trade wind belt but also in the doldrums. Besides, atmospheric disturbance in the form of tropical winds and waves also dominate the weather in the tropics. At the times, these areas experience an onslaught of air masses from the middle latitudes. In the view of the above, it does not seem logical to call the tropical weather as periodic. See, this is a textbook. It has told you, in addition, कि permanent conditions नहीं हो सकते tropics में, ये हमें पता ही है. कभी cyclones आता है, कभी east monsoon, northeast monsoon है, कभी southwest monsoon is there. Fine, so don't worry about this. It was also discovered that trade winds blow with regularity only in the certain parts of tropical oceans. Matlab, it is blowing with regularity only in Pacific and Atlantic, not in Indian Ocean, because Indian Ocean mein there is equatorial westerlies. It was also found that contrary to the general belief, the anti-trades in the upper air are not seen everywhere. They are limited to certain regions only. Based on the basis of above observation, it was confirmed that the consistency and the wind velocities of the trade wind dwindle on the poleward and equatorial margins. ये सब कोई काम का नहीं है, ये सब छोड़ दो. And therefore come to the part here. In fact, ये पेज को मैंने xerox करने के लिए इसीलिए कहा है, so that आपको हमेशा याद रहेगा winds in the tropical regions, तो ये 2 लिखना है. बस that was the only reason I had asked him to xerox this page. Otherwise, you can cancel all these things. Equatorial westerlies. Equatorial westerlies are most controversial aspect of the tropical wind system. No doubt, monsoon is very much less understood aspect. In this connection, 2 research papers were published by Fletcher and Flon. According to Fletcher, the zone of equatorial westerlies is located between north and south intertropical convergence zone. The understanding why north and south intertropical convergence zone? Because this is from where the equator is going. 0 to 5 degree north is north convergence zone, 0 to 5 degree south is the south intertropical convergence zone. The core areas of westerlies change their position with the changes in the season. ITCZ during the northern summers will shift to the north, and during the southern summers it will shift to the south, and therefore winds will keep on changing the position. Here we have, don't worry, equatorial westerlies हमें इतना कम नहीं, हम लिए लिखने वाले. So during this we have the southwest monsoon. अगर ITCZ नीचे है तो we have the northeast monsoon. This is the meaning of this statement. On the basis of observation, Flom holds that equatorial westerlies extend from western parts of Africa across the Indian Ocean to the western parts of Pacific Ocean. The longitudinal extent of this wind, according to him, covers 200 degree of longitudes. यहाँ से यहाँ तक is the monsoon type of climate. Monsoon is not limited to India only. You had a question also in last year's paper. What are the characteristics of monsoon type of climate that affects Asia, not India? So यहाँ से यहाँ तक is the monsoon, that is eastern part of Africa to the western part of Pacific, South China Sea tak. Fine. There are other meteorologists who ascribe the existence of these winds to large number of tropical storms and atmospheric disturbances. There are still other scientists who consider equatorial westerlies as recurved trades which have crossed the equator into summer hemisphere. मतलब जहाँ summer है. Fine. इसके बाद कल क्लास में आने से पहले you finish. I will discuss equatorial westerlies with much detail. You will come and read trade winds, because वो मैं लिखाऊंगा नहीं. Fine, उतना करके आना, कल के लिए मत छोड़ना. Do westerlies, do polar winds, Arctic and Antarctic में, and do tricellular cell. Tricellular cell. We'll meet tomorrow then. करोगे तो 1.5 घंटा बच जाएगा, जो जीएस में आप वैसे भी पढ़ने वाले हो. एंड जाके आज फिर से ग्रेडियंट विंड करना, बिकॉज कन्फ्यूजन नहीं तो रहेगा इफ यू डोंट डू इट टुडे.